Okay, for next question, we have to give reasons for the following. And the for first question, it says the danger signals installed at airports or at the top of tall buildings are red in color because the red color is scattered least, and it's scattered least. So that means when you see them in fog or smoke, they can be easily seen from a distance because they are not scattered and the red color remains at just one point. And this is because red color has high wavelength and the scattering is less. So answer for this is red color is least scattered by fog or smoke. So red color is this is least scattered. And these are installed at airports and top of buildings so that we can see them from the distant far away place. So either you can write that red color is least scattered by the fog or smoke and can be easily seen from a distance. Okay, now this is because we can also write the red color. I will explain you how. The red color has high wavelength and therefore scattering is less. Is less. Okay, let me show you how you might had observed this in the prism that when a white light passes through a prism, it splits up into seven constituent colors. So this is the white light. And when dispersion occurs, so these are the seven colors, one, two, three, four, five, six, and seven. And the first one is the red, and the last one is the violet. So this is the violet, this is the red. And if this ray of light was not going through the prism, would have gone, it would have gone like this. But now, so this is the original path of the incident ray. Now the red color has bent the least and the violet has bent most. So violet has the largest deviation, that means its wavelength is smaller because the red color has bent the least, its wavelength is the largest than the violet. So red color has high wavelength, thus its bend least and the scattering is less. So that's why red color is least scattered by fog or smoke and can be easily seen from a distance. So red color has high wavelength and the scattering is less. Now the sky appears dark to the passengers flying at high altitudes. Now let's suppose this is the Earth and let's say this is the atmosphere and we have air only in this region. Now let's say astronauts is viewing the sky from here. Now in between there is no air. So in between there is no air, so that means here scattering is not possible. So scattering is not possible. That means the particles of the air will not be able to scatter any of the colors, and hence for this the sky will appear black. So that's why the sky appears dark to the passengers flying at high altitudes, and for us it appears blue because we are viewing the Earth from the surface, and in between there is air. So here the scattering is happening, and very minute particles they scatter the color of the small wavelength, which is blue, because the size of the particles it matches with the wavelength of the blue color, and hence it scatters blue light. So what do you have to write here? The sky appears dark to the passengers flying at high altitudes. And answer for this should be there is no scattering of light due to lack of atmosphere at high altitude. So we will write there is no scattering of light due to, we can say, absence of atmosphere at high altitudes. So this is the reason for B. You don't have to draw this. This is just to explain. You don't have to draw this. This is the answer that you have to write, this one and this one. Okay, moving on to part C. The path of a beam of light passing through a colloidal solution is visible. So through the colloidal solution, the path of the light is visible because the particles of the collide are big enough. We know that the dependence of color, it depends on the size of the particles. Very minute particles they scatter color of smaller wavelength, and particles of collide are very big in size, and they are able to scatter all the colors. So it appears to us that it's a beam of light, white light. So that's why the path is visible to us. So particles of the collide are big to scatter the beam light to scatter. This is the beam light. That is, all the colors are scattered in same proportion, and we see the path of the light. So the path of the beam light through colloidal solution is visible because the size of the particles of collide are big enough to scatter the beam light. So it depends on the size of the particles, the color. With this, we are done with question number 31. Let's move on to next question.